and today we're going to show you guys the basics of an economizer for a packaged rooftop unit. We'll discuss what an economizer is, we'll show you some different vintages and types of controllers you might see in the field, and we'll show you how to do some basic testing to make sure things are operational. Let's go ahead and get started. So here at our rooftop, we have a view of a modern economizer as well as an older one, so we can help you compare them so you can see the differences on there. But first, let's explain a little tiny bit about what an economizer actually does. So the best way to think about it is at your house, if you're gonna have everybody over for Thanksgiving dinner, and it's gonna be really hot in your house, the oven's going, there's 30 people, if it gets too warm, you're probably not putting your air conditioner on, you're probably opening your windows to cool the house off. Well, in a lot of commercial buildings, we don't have any windows to open, or we have interior rooms that don't have any windows. So we need to do it a different way. We could run your rooftop and your air conditioner, but that's pretty expensive to do. So if it's 50 degrees outside, why not just bring the 50-degree air in? So what we do is we have an air inlet that sucks air into this unit, and we have a damper in there. Any of these blades we're talking about, the damper opens up and it sucks the free cold air in from outside and then uses your duct system to distribute that air everywhere it needs to go. So you get free cooling without running your compressor by bringing the outside air in. Now, these two ones that we're looking at here, there are some differences. A modern code-compliant economizer, typically like 2015 code and later, if you will have a couple differences to it. They need to be low leak dampers. So when they close off, typically at nighttime when no one's there, it's sealed tight, and in the wintertime, we don't allow a bunch of extra air to leak into the building. What that means is on the ends of these blades, I know you can't see very well, there's seals on there, on the ends and on the edges. And then when it shuts, that keeps everything nice and tight. The other major visual difference you'll notice is these gears here. So when this motor turns the gears to move the damper blades, these gears are on the outside of the airstream, not outside the rooftop unit, just outside of this airstream. Whereas on this older style one right here, those same kind of gears are on the inside of the airstream. So this is my airstream here in, this is outside. So when the gears are on the inside, they can't be perfectly tight, so air is able to leak around them. By the new design moving it to the outside, the air is not going around them anyway, so it doesn't matter. So we have less leakage through those guys. From a control standpoint, you can have all kinds of different controls. I'm going to show you two types right now because they are by far the most common. So this controller right here is made by Honeywell. It's called the Jade Economizer controller, and it's probably the dominant controller you see on rooftops that are put in the past 5 years or so. The controller is probably 7 or 8 years old, but it got more popular recently. There's a whole display on here. There's like 40 some different screens you can go through to configure stuff. That's pretty common, and it's one of the few that are code compliant. The Belimo Zip would be another one that's code compliant. But you're not going to see a lot of those on existing units. So this one here I'll show you. This is the economizer we were looking at before. It's a little bit older. This also has a Honeywell economizer controller on it. This one's a 7212 series, and there's even older ones than this, but you'll see this a lot. This is super common. Of the same era, this would be like 1990s, early 2000s, this would be common. So a lot of the stuff you guys are working on. In this same era, you'd also see a decent amount of controllers from Johnson as well. So on this guy, there's a bunch of different little potentiometers down the side. A couple of them are interesting to us right now, mainly for the purpose of testing stuff. This one that says minimum position is key. So one of the basic tests I'm going to do on this economizer is to open the damper all the way and close the damper all the way and just make sure it fully moves. These ones, like we said before, are gear driven. There's also other ones that have linkage arms and all kinds of other stuff like that. But if I can stroke it all the way open and I can stroke it all the way closed, I know at least nothing is mechanically broken. So the easiest way to do this one on the minimum position dial is take your screwdriver and just turn it clockwise all the way to the 100% position. And the damper will just move all the way open. And as long as it physically opens all the way, you're good. And then take your screwdriver and turn it back all the way the other way and make sure it goes all the way closed. You might want to make note of where it started at though, because that's probably where you're going to leave it when you're done. Whereas on these newer style Jade ones, we're going to do it from a screen. And we'll go ahead and do that now. On this style here, on the Jade version, we're going to do the same kind of thing we did with that potentiometer, clockwise, counterclockwise, but we're going to do it from a digital screen. So right now it says status on the screen. I'm going to scroll down a few times until I get to checkout. I'm going to hit enter there. And then I'm going to scroll down to where it says damper open. I'm going to hit enter again. It says, do you want to run this? I'm going to say yes by entering enter. And now it says test running. And now the damper physically is going to start modulating open. Now in this case, it's on the other side of that rooftop unit that we're working on, but it looks like this. It's going to modulate open. I'm going to make sure it goes all the way open. And when it's done doing that, what I'm going to do is go back to the controller, and I'm going to hit the escape button on the left to leave there. Then I'm going to scroll down to damper closed. I'm going to hit enter. Do you want to run it? Yes, enter. Test running. And now that same damper that we just drove open is now going to drive itself shut. Now I'll be able to make sure it goes all the way open, all the way shut. And I shouldn't have any gap or limited range on there. Full range I should see. And when I'm all done, I can come back to the controller and I can hit the escape button on the left a couple times until I go back over to the status screen. And then I at least know the damper physically moves. There's a whole bunch of other stuff we can do with this controller, but that's a basic test just to make sure I can move my damper open and close. Now, let's say that there is a problem, right? We did some basic stuff, try to stroke it open, try to stroke it close, but some of the more common problems that you're gonna find, by far the most common problems are usually caused by us, operators. So sometimes you'll find things that are propping the economizer open, like a 2x4 just shoved up into the damper there. Usually that's because maybe they didn't have cooling for some reason, the compressor was down, and they want to get some airflow going into the space, so they propped it open with a 2x4 and then kind of forgot about it, right? So obviously that's one. Sometimes it's the opposite. Sometimes the economizer gets screwed shut. Somebody sees cold air getting sucked in the winter. They think that that's a bad thing, even though it's actually a really efficient thing. And they go with some zip screws and they zip, 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 and close that thing down. So obviously taking those screws out and allowing full operation is a benefit. Sometimes people will put in bad set points. Like normally we want a mixed air temperature set point of like 53 to 55 degrees. We want an outside air cutoff set point, assuming you just have a dry bulb economizer, of about 62 is a good number. If you set it lower, like the historic 55 number, that's too cold. If you set the outside air higher, you could have little problems with some humid days. So 62 is a good number for a dry bulb economizer. Sometimes you'll see things that are completely configured and functioning correctly and the actuator's spinning, but it's no longer attached to the shaft. It's just spinning, right? And hence the damper doesn't move. So clamping that shaft back down would be something you need to do to fix that. And then beyond that, things get a little more complicated. Maybe you got a building automation system involved. Maybe you have some thermostat programming that's incorrect. Maybe you have wiring errors. Lots of stuff to look at. But those are some of the basic things that you could probably fix pretty quickly before you need to call in and get help from somebody else.